Okay, guys, we are looking at gas laws today. So we have some of our factors here for gas laws: pressure, volume, temperature. So we're going to talk about those a little bit first, and then we're going to do Dalton's law. So for pressure, we have force per unit area. And that's its technical definition. What that's going to look like in chemistry class is particles colliding or particle collisions with the container. And y'all have seen that a few times. The SI units for pressure are kilopascals, and we will see that in some of our work, but we'll also see atmospheres, and that's ATM. So we'll have both of those present in these. So if you see those, they go together. Okay. Our next one is volume, and we learned this week that a volume is the space that matter occupies. And our SI units for that are cubic centimeters, and we saw that in our GIM kit, but we will use liters, and that will be abbreviated as L. So if you see liters anywhere, think volume. And then our last variable here is temperature, and that is the average kinetic energy, which you guys know by now. So we have high temperature, we have high average kinetic energy. If we have low temperature, we have low energy. The SI units for this is Kelvin. And all of our work will be in Kelvin. So if you see that capital K, that's what it is, temperature. Now, in Kelvin, there's something special called absolute zero, and that is 0 degrees Kelvin. That is the point that there is no more particle motion. Okay, so we're going to start with our first gas law, which is Dalton's law. And I think it's one of the easiest. That is why we are starting with Dalton's law. Trying to get to the picture, which is down here. So we're going to zoom in on this. So Dalton's law of partial pressure is usually when we have unreactive, well, it is when we have unreactive gases that will just physically combine and not chemically combined. And each gas will have a different pressure. So the first one could be maybe oxygen, O2, we might have nitrogen, and maybe hydrogen. So you can see in the second picture all the colored dots together, but they haven't chemically combined. They're still separate dots. So what this is, if we take this number and we add this number and this number, we get our total number of 1350 kilopascals. So this one is using those kilopascals to measure pressure. So in their individual containers, they're at a lower pressure, but when they're combined, it is at a higher pressure together. So these ones are going to be really easy. We're pretty much just adding up the numbers they give us. We might have to do a little bit of algebra on that second one, but I think y'all are going to do fine. So again, the variables for Dalton's law is just pressure. That's all we're looking at. And the formula is PT for total pressure. And that's the first pressure plus the second pressure plus the third pressure. And that could go on forever, depending on how many gases you have. So in our first one here, our question says find the total pressure for a mixture that contains 4 gases at partial pressures. So we have 7.00, we have 5.56, we have 4.02, and we have 2.20. So for this problem, we're going to have a formula of PT equals P1 plus P2 plus P3 plus P4. So we're just going to add these up. And that comes out to be 18.8, and that would be in kilopascals. Okay, our next question. And this one says both A and B are unreactive and allowed to mix. The total pressure is 3.50 atmospheres, and if B was measured to be 1.25 atmospheres, what is the partial pressure of A? So we used 1, 2, 3, and 4 in our last one. This is using A and B, so we can do that too. We can just say that our total pressure is equal to the pressure of A plus the pressure of B. Okay, it gives us the total pressure, so I'm just going to put that in here. And then it gives us the second pressure. And so we are left to find the pressure of A. So we're going to have to do a little bit of algebra. So I want to get PA by itself. I'm going to subtract 1.25 from both sides. So I can cross those out. And we have oops. Okay, so our final answer is partial pressure A equals 2.25. And on this one, we used atmospheres, ATM. Okay, so that is all for Dalton's law.